Welcome to tonight's video on part 3, geometric sequences we'll talk about here. A geometric sequence is a sequence in which basically you multiply to go from term to term. So here notice this sequence is geometric because you're multiplying by 2 to go from term to term. That number we're multiplying by here is what's called the common ratio, R. That's the number you multiply by to go from term to term. You can get the common ratio. You can get the common ratio by dividing the previous term or the next term by the previous term. And that is what's called the common ratio. Now, there's two types of definitions for geometric sequences. There's the explicit definition, which says that to find any term, you take the first term times the ratio to the n minus 1. Kind of similar to what we did with arithmetic, except now we're raising it to a power because we're multiplying. And the recursive definition, which says to get the next term, you take the previous term and multiply it by the ratio. So that is the recursive definition. So if we look at some computation here, if we take the 10th term and divide it by the 4th term, so the 10th term divided by the 4th term would give us the 6th term. Actually, sorry. Let's write it out. So the 10th term is the first term times the ratio to the 9th. And the 4th term is the first term times the ratio to the 3rd. And 10 minus 4 is 6. So we're taking the 6th root. The a sub 1's cancel out of r to the 6th, and that will be the absolute value of r. Whereas here, it's the 5th root of a to the first term times the ratio to the 7th, and then this one's the first term times the ratio squared. So it's the 5th root of r to the 5th, which in this case is just r. So in conclusion, if you take the difference, the root of the difference of the term numbers, and take that of the one term divided by the other, you are going to get the absolute value of the ratio or the ratio, one or the other. Geometric means are the terms between any two terms in a geometric sequence. So just like we found arithmetic means, we are going to be able to find geometric means. And if we're just finding one of them, it's just going to be the square root of the product. That is the geometric mean. So let's do some examples here. So for the following geometric sequence, find the ratio, the explicit and recursive definition, and then find the 21st term. So first of all here, if you notice, it looks like we're multiplying by 2, so that's the ratio. To find any term explicitly, we take the first term times the ratio to the n minus 1. And then for the recursive, the next term is going to be equal to the previous term times the ratio, which means it's 2 times the number of term, where the first term, which will be t sub 1, is equal to 3. To find the 21st term, we'll use the explicit definition and put 21 in for n, so it's equal to 3 times 2 to the 20th, which is 3,145,728. All right, so for the next one, they give us the 4th term and the 8th term, and they say it's a geometric sequence, and we want to find the ratio So remember, the ratio can equal the root of the difference of the term number, so 8 minus 4. Oh, sorry, it's the third term, so it'd be 8 minus 3. And over 128 over 4. So the fifth root of 32, which is equal to 2. So that is the ratio. So if 2 is the ratio, that means working backwards. If the third term is 4, then the second term is equal to 4 divided by 2, which is 2. And the first term would be 2 divided by 2, which is 1. So to come up with an explicit definition for P sub n, it's equal to 1 times the ratio 2 to the n minus 1 power. And then recursive, P sub n plus 1 is equal to P sub n times 2, which you can write as 2 P sub n, where P sub 1 is equal to 1. To find the 17th term, we will go 2 to the 17 minus 1 power, which means it's 2 to the 16th, which is equal to 65,536. All right, looking at number 3, it gives us the first term and it gives us the fifth term, and it wants us to find the ratio explicit definition. So once again, the ratio is going to be the root of 5 minus 1 over 80 divided by 5. So it's equal to the fourth root of 16, which is 2. The explicit definition is going to be J sub n equals 5 times 2 to the n minus 1. The recursive definition is the next term is equal to the first term, or sorry, the previous term, times 2. So it's 2j sub n, where the first term is equal to 5. And to find the seventh term, we're going to go 5 times 2 to the 7 minus 1 power. And that is equal to 320. So to find the geometric mean of 1 and 20, so just one of them, you take the square root of 1 times 20, which is 20. So the geometric mean would be 2 rad 5. For number 5, the geometric mean, of negative 5 and 80 would be the square root of negative 400. And so this is not possible because for all geometric means must be positive. We must have a real number. So find the geometric mean of x squared, y squared. So it'd be the square root of x squared times y squared, which means you'd have the absolute value of xy. That would be your geometric mean. And if you want to insert 3 geometric means between 1 and 16, so that means you have 3 spaces and then 16. So that means to find the ratio, you go 5 minus 1 over 16 divided by 1. So the fourth root of 16, which is 2. And it actually could be plus or minus 2. So here, and actually, sorry, let's go back up to number 4, because I forgot. If you're taking the square root of 20, it could be plus or minus 2 rad 5. And here, let's change that to a real number. All right, so yes, the fourth root is plus or minus 2. So basically, if r is 2, then the geometric means it's 1, 2, 4, 8, and then 16. But if r is negative 2, then you have 1, negative 2, 4, and then negative 8, and then 16. So depending upon what the ratio is, it's either positive or negative 2 that determines the geometric means. So number 8, for what value of k will it form a geometric sequence? So remember, to find r, you take this term, the second term, divided by the first term. Or you could take the third term divided by the second term. So these are going to be equal. And then you multiply, cross multiply, so you get 2k squared minus 10k plus 8. And then here, when you cross multiply, you get k squared minus 2k plus 1. Combine like terms, so you get k squared minus 8k plus 7 equals 0. And then factor, so you get k minus 7 and k minus 1 equals 0. So k equals 7. Or k equals 1. So then, if k equals 7, the terms are 3, because 7 minus 4 is 3, 6, and 12. So the ratio would be 2. Now, k cannot equal 1 because notice that would make the ratio undefined here. That would make the ratio undefined in this part. So k cannot equal 1. It does not work in the domain of that function. So the only one is if k is equal to 7. So you have 3, 6, and 12. All right, I hope you enjoyed this video. And if you have any questions, please feel free to ask. Have a good evening.